3, so it says the speed v kilometers per hour of each of 200 cars passing a building is measured. The table shows the results. So we're given a grouped frequency table, and in part A I need to find an estimate of the mean. So whenever I'm given a grouped frequency table, the formula for the mean, which is x bar, is the summation of fx over the summation f. So what's the summation fx? Now f is the frequency and x is the midpoint. Now how can I find the midpoint of each class? Now, for example, for the first class, which is v between 0 and 20, to find the midpoint, I need to add the lower bound to the upper bound, and then divide the answer by 2. So 0 plus 20 over 2 is 10. So the midpoint here is 10. Now for the second class, it's 20 plus 40 over 2, which is equal to 30. For the third group, it's 40 plus 45 over 2, and the answer is 42.5. For the fourth group, it's equal to 47.5, then I have 55, and finally 70. So again, to find the midpoint, add the lower bound of the class interval to the upper bound of the class interval and divide the answer by 2. Now to find summation fx, we need to multiply each midpoint by its frequency. So I need to multiply 10 times 16, 30 times 34, 42.5 times 62, 47.5 times 58, and so on. So 10 times 16 is 160, plus 30 times 34 is 1020, plus 42.5 times 62 is equal to 2635, plus 47.5 times 58 is 2755, plus 55 times 26 is 1430, plus 70 times 40 is 280. All of it is divided by the summation of the frequencies, which is 16 plus 34 plus 62 plus 58 plus 26 plus 4, which is equal to 200 as given in the question. So add all the numbers and divide by 200, the answer is 41.4. Now in part B, it says use the, or part BI, it says use the frequency table to complete the cumulative frequency table. So the first entry is 16, the second entry is 50. So how did they get 50? They added 16 to 34. So they added 16 to 34 and the answer is 50. Now to find the cumulative frequency when V is less than or equal to 45, I need to add 50 to 62 and the answer is 112. And to find the cumulative frequency when V is less than or equal to 50, so it's 112 plus 58 and the answer is 170. Now, in part I, it says on the grid, draw a cumulative frequency diagram. So I already did that. So what you have to do is that you need to plot the points that are shown in the table in part BI on the grid. So when V is 20, the cumulative frequency is 16. When V is 40, the cumulative frequency is 50. When V is 45, the cumulative frequency is 112. So you need to plot all these points, and once you have all the points plotted, you need to draw a smooth curve connecting all the points. And that's how it should look like. Now, in part III, it says use your diagram to find an estimate of the upper quartile. So the upper quartile, so first we need to find the position of the upper quartile, which is 75% or 3/4 times the sum of all frequencies, which is 200 cars. So 200 times 3 over 4 is equal to 150. So 150 here is not the upper quartile. It's the position of the upper quartile. Now, after I find the position, I go to the y-axis, and when the cumulative frequency is 150, so it's somewhere over here, I need to move horizontally until I meet the line, the purple line, the cumulative frequency graph. So it's this point over here. So I need to go down, and the x reading, the speed, is equal to 48. So basically here, once you find the position of the upper quartile and it's equal to 150, you need to go to the cumulative frequency axis, the y-axis, take a reading at y equals 150, move horizontally until you meet the line, the curve that we drew, and then go down to the x-axis and take a reading of the speed. So that reading would be equal to 48. So the upper quartile is 48. Now in part B, it says find the number of cars with a speed greater than 35. So using the cumulative frequency graph, I'm going to find the number of cars that have a speed 35 or less. So when the speed is equal to 35, so 35 is somewhere over here. So I need to go up and take a reading, and that reading is equal to 40. So it's this reading over here, so it's 40. So the number of cars that have a speed of 35 kilometers per hour or less than 35 kilometers per hour is 40. Now to find the number of cars with a speed greater than 35, I need to subtract, or I need to do 200, which is the total number of cars, minus the number of cars that have a speed 35 or less, which is 40. So 200 minus 40, the answer is equal to 160. So 200 minus 40, the answer is 160. Now in part C, it says 2 of the 200 cars are chosen at random. Find the probability that they both have a speed greater than 50. So again, let's find the number of cars that have a speed greater than 50. So again, to find the number of cars that have a speed greater than 50, so I need to go I need to go to the x-axis. Now when the speed is 50, I need to go up until I meet the curve and take a y reading, and that y reading would be equal to 170. So it's over here. So this reading is 170. So that's the number of cars with a speed of 50 or less. So to find the number of cars with a speed greater than 50, I need to subtract or do 200 minus 170, and the answer is 30. So 200 minus 70, 170, the answer is 30. So 30 are the number of cars that have a speed greater than 50. Now, of these 30 cars, I'm picking 2 cars at random. So what's the probability that both cars have a speed greater than 50? So now I have 30 cars in total that have a speed greater than 50. So if I'm picking the first car, what's the probability of getting a speed greater than 50? It's 30 divided by the total number of cars, which is 200 times. Now I want to pick a second car. Now the probability that the second car will have a speed greater than 50, it's not 30, it's 29, because I already picked the first car. So the number of cars that have a speed greater than 50 will be less by 1. And since they will be less than 1, so the total number of cars will be less by 1 too. So the probability is 30 over 200 times 29 over 199, and the answer is 87 over 3,980. Now, in part D, it says a new frequency table is made by combining intervals. And on the grid, draw a histogram to show the information in this table. So, now, whenever we are asked to draw a histogram, we need to find the frequency density. And the frequency density is simply the frequency over the class width. Now, how can I find the frequency density for each interval? Now, for the first interval, where the speed is between 0 and 40, the frequency density is the frequency, which is 50, divided by the class width. And what's the class width? It's 40 minus 0. So 50 over 40 is 1.25. For the second interval, the frequency density is 120 divided by 10, because the class width is 50 minus 40, and the answer is 12. And for the last one, it's 30 divided by 30, and the answer is 1. Now I have the frequency densities. I can now plot my histogram. So when the speed is between 0 and 40, the frequency density is 1.25. So when the speed is 40, the frequency density is 1.25. Now, for this grid, each block on the y-axis represents 0.5 units. So when the speed is 40, each block is 0.5. Yeah, so I need to go to 1.25. So this is 1.51, 1.52. So it's somewhere here. Now I need to draw a horizontal line, and this is my first bar. Now for the second one, it's between 40 and 50, and the frequency density is 12. So when the frequency density is 12, it's 10, 11, 12, it's over here. So I need to draw a line, and this is my second bar. And for the last one, when the speed is between 50 and 80, the frequency density is 1. So between 50 and 80, it's 1, so it's over here. So this is the frequency, or this is the histogram. So this is my histogram. Great. Now let's do question 4. So in question 4, it says the diagram shows two triangles, and in part A I need to find QR. So QR. Now for triangle PQR, so this is PR, this is RQ, and this is PQ. So this is R, this is Q, this is P. And the angle is 25. Now PR is 150, PQ is 120. Now whenever we are given a triangle with two known sides and an angle in between, we need to use the cosine rule. So to find QR, it's simply the side that is opposite to the angle in question, so it's QR squared is equal to 120 squared زائد 1 or plus 150 squared minus 2 times 120 times 150 times cosine the angle, which is 25. So so the answer would be equal to QR squared is equal to 14400 plus 22500 minus 32627.8 0.0803. So on your calculator, you need to evaluate 14,400 plus 22,500 minus 32,627.0803, and then apply the square root of that answer, and QR would be equal to 65.367. So it's equal to 65.4. So QR is 65.4 meters. Now in part B, we need to find RS. So we need to find RS. Now I can find the angle at S. How? Now since PRS is a triangle, and the sum of all the angles inside a triangle is 180 degrees. So to find the angle at S, I need to do 180 minus the angle at P, which is 55, minus the angle at R, which is 45. So 180 minus 55 minus 45, the angle is 80 degrees. Now, how can I find RS? So here, if I use the sine rule, so I say sine 80 over the opposite side, which is 150, is equal to sine 55 over its opposite side, which is RS. And now I can cross multiply. So RS times sine 80 is equal to 150 sine 55. And to find RS, I need to divide by sine 80 to get rid of the sine 80 in the numerator, and of course the right hand side by sine 80. So RS is simply 150 times sine 55 divided by sine 80. So RS is equal to 124.77. So RS is 124.77, which is equal to 125 meters. So RS is 125. Now in part C, we need to find the total area of the two triangles. Now to find the total area of the two triangles, I need to find the area of triangle PQR, and then I need to find the area of the triangle PRS and add them up together. So how can I find the area of the triangle PQR? I'm given two sides and an angle in between, so I need to use the formula, which is half times A times B times sine C. So the area of the triangle PQR is half times 120 times 150 times times sine 25, and for triangle PRS, I'm going to use half times A, which is 150, times B, which is RS, and it's 125, times the angle in between, which is 45. So we found that RS is equal to 125. So I'm going to use the two sides, 150 and 125, and the angle in between, which is 45. Now let's do that. So the area of the triangle, of the first triangle, which is PQR, is equal, so the area of PQR is equal to half times A, which is 120, times B, which is 150, times sine the angle, which is 25. And the answer is 3.564. Now for the second triangle, which is, I think it's PRS. Yes, PRS. It's half times 150 times 125 times sine 45. So area of PRS is half times 150 times 125 times sine the angle in between, which is 45, and the answer is 6616.9284. So to find the total area, I need to add up the two areas of PQR and PRS. So the total area is 3803.564 plus 6616.9284, and the answer is 10,420.492. So to three significant figures, it's 10,400. So that's the total area of the two triangles.